In this lesson, we're going to get an introduction to using LLVM to transform and optimize programs. LLVM is an extremely popular compile infrastructure for C and other languages like Rust. Before you ask, LLVM no longer stands for anything. It has a really cool dragon logo that you can check out. It has the reason we're going to use LLVM is that it has a really nice SSA form IR and an amazing API for manipulating it that makes it possible to be very productive very quickly by designing your own modular pass that transforms programs. In one very abstract sense, it is like a supercharged version of Brill, which you've been using thus far in this class. That's not really coincidental because I modeled Brill after it. That is, the language that is the Brill IR is like a kind of idealized form of the LLVM intermediate representation. It is also, in a different way, kind of the opposite of Brill, because LLVM is real infrastructure that the world really runs on. That is, there's actually a very high chance that some software along the chain that you are using to watch this very video was compiled with LLVM. It's like serious infrastructure that people really use. Brill is not. Brill is an educational tool. So it is like 10 million times more realistic than Brill, which is amazing because it will let us compile and run like real software and to transform programs to run on like real architectures and to use an existing library of lots of amazing optimizations. However, on the other hand, there's a trade-off here. Because LLVM is so realistic, it also is less friendly to use than Brill. A lot of the ways in which Brill is kind of idealized are ruthlessly realistic in LLVM. So we'll have to deal with a lot of those kind of these aspects of realism that we didn't have to deal with in Brill by sort of ignoring stuff like opening files, for example, which we were conveniently able to do when using Brill. I also should mention that LLVM is written in C++, so we're going to write some code in C++, and that's just the way that it is. And this is a big contrast with Brill when you could use whatever language you like. In this lesson, we are going to use a tutorial that I wrote on my blog a very long time ago that is still relevant. It's called LLVM for grad students, and you will find a link to it in the notes associated with this lesson. This will walk you through the concepts behind LLVM and get you started by writing a pass that can manipulate code using the LLVM infrastructure. I'm not going to say every single word that's in the blog post, so I encourage you to read the blog post alongside the video. The first step that you're going to need to do is to install LLVM. I'm not going to cover this in detail either, except to say that it is probably in whatever package manager you use. For example, I'm on macOS, so I use the Homebrew package manager, and I can just do brew install LLVM. This is a note for Mac users. You will need for this tutorial to install LLVM separately, ideally from Homebrew, instead of using the one that comes with Xcode. This makes it possible to write passes. You will also need CMake. So this is the full command that you need on Homebrew on the Mac, but you can find some additional notes in the tutorial that might point you in the direction of how to install LLVM on your system. Please pause the video now and ensure that you can install LLVM to the point where you can write Clang version and you get something like this, ideally Clang version 10 point something or other. Do that now. Great, now you have LLVM installed. Now you can check out what its intermediate representation looks like, what the supercharged version of Brill looks like as a programming language. We're going to do this by writing a C program. So I'll just do this one very small C program. It's the smallest one I can reasonably write without being embarrassed. We'll just do like int x is 42, and then I'll return 42 from this function. Don't go crazy at first. We're going to compile this program with Clang. Clang is the C language frontend for LLVM. It parses and compiles C programs to LLVM's internal representation and then uses LLVM to compile it the rest of the way to machine code. However, we just want to print the internal representation instead of compiling all the way to machine code so we can see what it looks like. To do that, you need a few magic flags. You'll do emit LLVM with a single dash and -s, which tells it to do assembly instead of emitting binary. And then we can say -o dash to have it just print to standard output instead of writing to a file. Of course, you can have this write to a file if you prefer. And then I'll just give it the name of the C program I'm compiling. So that was fast. It has compiled it to its intermediate representation. There's a whole bunch of stuff here that is somewhat hard to interpret, but the main thing that's going on is this definition of a function. And you can see maybe here what I mean by this sort of resembling Brill. That is, we have a definition of a function here. The name is main, which comes right from our source program. And then there's a list of instructions. Some of the instructions are even named exactly what they're named in Brill. For example, there's a ret instruction that returns a value from a function. The type system is quite a bit more complicated in LLVM. The first thing that you'll notice is that integer types have arbitrary width. So i32 is the type of a 32-bit integer, which LLVM has used to implement this C program for me. You'll notice that the body of the function is made up of these like allocate instructions that create space on the stack, and then some stores, and then loads, and then finally a return. And you'll see that there are variables being used, just like in Brill, to store the intermediates. So for example, 1, 2, and 3 are all variables that are sort of stack local. That is, they're local to the function. You can think of them as roughly like the variables that we used in Brill programs, that we assign to and read from in Brill programs. However, LLVM is an SSA IR, so unlike Brill, which can either be an SSA form or not, every LLVM program is in SSA. So when we refer to like %3, for example, that's just a nice convenient name that it makes it possible to read this program in text format. What's going on actually in LLVM internally is that this ret instruction has a pointer to this load instruction and says that it gets its value from there. So LLVM is really, at the most basic levels, kind of baked in this LLVM philosophy. To begin your journey as an LLVM hacker, an important thing to do is to get familiar with the documentation. You'll often be going to the documentation to understand basically anything that's going on in LLVM. One big thing that you'll want to look up all the time is what instructions do. That is, what is this allocate instruction? What is store? What is load? What is ret? For answers to those questions and more, you'll want to use LLVM's language reference. You can Google just like LLVM langref and you'll get this page. This is a very long document that includes a whole bunch about the structure and the type system of LLVM, but also descriptions of individual instructions. For example, we can look up that load instruction, and we will get more detail than we could possibly have wanted about everything that can go into load instructions and exactly their semantics in the context of LLVM programs. You'll want to acquaint yourself with the LLVM language reference as you go through this lesson. Another big thing that you'll want to use, and you'll see me reference this a lot in the next video, is the internal Doxygen-based documentation that's generated for the LLVM API. For this, I'm constantly turning to Google to just search LLVM and the name of the C++ class or method that I'm looking for. For example, I can look for LLVM value, and I've at least trained my Google bubble to take me to the LLVM Doxygen stuff. There's a whole bunch of information here, including the class hierarchy and everything that this class contains. I can't stress this enough. When you're using LLVM, you constantly have to be looking at the documentation. I don't really know a better way to navigate LLVM and to become an LLVM expert than constantly reading the documentation. You'll have a browser in one hand and you'll have a text editor in the other, and this is the way that you'll make your way through the LLVM ecosystem. Please take a look around the documentation, try compiling some C programs and see if the IR looks interesting to you, and ask questions on Zulip. In the next video, we'll walk through writing a pass that can transform LLVM programs.